Hello everyone. So this video, we're gonna talk about the practice project. We'll use this data is weight.sav. We already upload this data file on Blackboard under the SPSS folder, so you can just go there and then download this file to your local computer. And then you can double click on the file and then you see what we have here. So we have the first column, the variable name is weight, and then all the 13 numbers. This is just the same example we've been using uh, from the lecture notes, and also we use the same example for the SPSS project video. And the second column, we have the group variable, and then is a qualitative variable. We have 4 different groups. And then after kind of getting know the data, let's start. First thing we want to do is we want to sort the weight column in an increasing order. So this is already properly sorted. But let's just treat this column is not properly sorted. And then what we're gonna do, we're gonna click on data and then sort cases. And the weight is originally here. We're gonna move that to sort by. And then the sort order gonna be increasing or decreasing. We will choose increasing and then click on OK. And then you can see everything's properly sorted. No worry about the group. So the weight 129.2 was group A. When you click on sort, those gonna move at the same time. So no worry about this column. It's gonna be aligned based on the increasing order we have on the weight column. And then after we properly sort everything, we can actually generate a qualitative frequency distribution based on the categories we have. So then we can write down the class or category, and then frequency, which is the count. Of course, we can also do relative frequency, but I think we just need the frequency column at this point. So for class, we have A, B, C, D, right? 4 different categories, A, B, C, D. And then for A, we have 1, 2, 3, 4. So we have 4 people that they are assigned to group A. And then for B, we have 1, 2, 3 for group B. And for C, we have 1, 2. And then for D, we have 1, 2, 3, 4. So that's all the frequencies. And now let's add everything together. We have 7 plus 9, that's 7 plus 2, that's 9, plus 4, 13. And all together we have 13 numbers, so no problem in the counting. And then we can actually make a bar chart or pie chart based on this qualitative frequency distribution. So we can just start from another column and type in the qualitative frequency distribution there. So this one we call, let's name it as class, and then the type gonna be qualitative, so we choose string, and then align at the center. I'm gonna go back and then type in all the different classes we have, C and D. And then for this one is the frequency, and it's numeric and decimal since it's count integer. So we reduce that to 0, align at the center, go back to data view, and then we type in the frequencies we have. And then we can generate the relative frequency using the computer. So we're going to go to transform, compute variable, and then the target variable, we call it RF, relative frequency. And then the formula we're going to use, or the numeric expression we're going to use, is the frequency divided by the total, which is 13. 13. And then click on OK. We have the relative frequency column. We can adjust the decimals to 4 and then align at the center. So then we can just make a bar chart and pie chart using this qualitative frequency distribution. So we're going to go to graphs and then legacy dialogues. Let's do the pie chart first, and then we're going to select pie and then click on values of individual cases, define, slice represent. For pie chart, we're gonna use the relative frequency, and then the variable gonna be the class, and then click on OK, and we can see the pie chart under the output window, and then double click on the pie chart. We get into the chart editor, and then we can click on elements and then show data labels to see that all the percent in the different slices. And then we also want to know what class it is. So then we're gonna move that class to the displayed window and then click on apply and then close, exit out. So then we have a pie chart here. So group A, that's 30.77%, group B 23.08%, group C 15.38%, and group D 30.77%. And we have 4 classes, 4 categories, and then with 4 slices here. Altogether, that's 100%. The reason we have a lot of different colors here is because the first data column we have up to 13 numbers. So the software kind of treat these 2 columns as missing values with all the dots. So that's why the pie chart automatically give a color for those missing values. So when you create this categorical frequency distribution or qualitative frequency distribution, you can start a new a data window and then type those into the new one like this, and then work from here. Then you won't have the issue of showing more than 4 classes or whatever classes is for your real data. Okay, that's about the pie chart. And then let's look at about the bar chart. Let's now copy that to the new one. Okay, so we have a new data window, and then we're going to click on graph, Lexi dialog, and then click on the bar, simple values of individual cases, click on define, bars represent relative frequency or frequency for a bar chart. So let's just choose relative frequency and then variable, that's class. Click on OK. Then we have this bar chart, A, B, C, D, different percentage. Or if we want to report the frequency one, then we're going to go to graphs, all the same procedure again. Lexi dialogs, bar, define, and then we're going to move that back, and then we just use frequency. Click on OK. That's the frequency, qualitative frequency distribution with frequency as the y-axis. So 4, 3, 2, 4, 4, 3, 2, 4. And this is the relative frequency or percentage one. That's the pie chart and bar chart. And then we can also only focus on the weight data, and then use this column to generate a histogram, right? So then we need to develop a frequency distribution, quantitative frequency distribution. So let's do that first. We have to calculate the width first. That's the range, 278.8 minus 129.2 over the number of classes. Usually we do 5 for a small sample size data, but this one n equals 13 is very, very small, so we can reduce that to 4. So the proposed classes is 4. And let's see what we have here. So let's use the calculator. 278.8 minus 129.2 divided by 4, that's 37.4. And then we just run up to 40. Since the range of the data is kind of large, so run up to 40, no problem. And then we can start to make the frequency distribution. Frequency and relative frequency. So we have class start from the smallest number, 129.2, to smaller than 169.2. 169.2 to smaller than 209.2. 209.2 to smaller than 249.2. And 249.2 to smaller than 289.2. So the width is 40. That means the upper limit minus the lower limit always equals the width, which is the 40. 289.2 is larger than 278.8 here. So we can stop here and then just count. 129.2 to 169.2, we have 6. 169.2 to 209.2. We have 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5. 5. Because 209.2 to 209.2 is going to be and enter this category because that's smaller than, that's exclusive. So then we have 1 here, 249 to 289.2. We have 1, so that's 13, no problem. And then that's our frequency distribution. For relative frequency, we can write that out. But when we draw the histogram, we can just use the frequency column. So we really don't need this information. But let's just complete this frequency distribution table. And then we can go to analyze descriptive statistics, and then we're going to choose frequencies. And then we're working on the weight variable, so move that to variables to let SPSS know what we're going to work on. And then click on charts and make sure we select histogram. Click on continue. Okay. So then under the output window, we have the histogram there, but that's not the one we want. We want the histogram exactly match the frequency column 6511. So that's our distribution. Then we double click on the histogram, get into the chart editor, and then double click on any bars there to get into the properties, and then we want to adjust the binning to custom. We have an interval width, that is the width we calculated, 40. And then the starting point is the smallest number in the data set, which is 129.2. Enter that, click on apply, close. So then we have the bar hat matches the frequencies 6511. But the scale is not quite right. All the cut points not show there yet. So we click on any number here and then double click on that. We go to scale. So the minimum, we're going to change that to the smallest number in the data set. The maximum to 89.2. So the largest number in your last class. Note that this is not the maximum number. This is whatever you put here in your frequency distribution. And then the increment is just a width of 40. Click on apply, close, exit out. Under the output window, you have a exact histogram matching what we developed. 129.2 to 169.2 to 209.2 to 249.2 to 289.2, 6511. So that's the cut point grouping method, and then histogram. So that's more like the graphical way, and then we can also report some statistics to look at the data in a numerical way. For that, we're going to go to Analyze Descriptive Statistics, and then we click on Frequencies. We're going to work on Ways, and then now we, instead of clicking on Charts, we need to click on Statistics. And then we're going to select what we really want. We can do 5-number summary, that's all the quartiles, and then the minimum and maximum. We can click on Continue, click on OK. Then the 5-number summary is shown here. So 129.2, that's the minimum. Q1, 185.1. Q2, 170.1. Q3, 185.35. And then the maximum, 278.8. So that's the 5-number summary. We can also draw a box plot